Welcome to the online classes. We have to complete it. 4 chapters, that is to be moving charges. Now we have to see here the basic torque values and how the force is acting on current carried by force on current carrying wire. So we have to take a simple wire and take the differential length, that is to be DL, and current I, that is to be flowing in the wire. So we have to see that the magnetic field that is to be placed, and this is the magnetic field, and the force that is to be acting, that is to be the magnetic force that is to be the acting on the particle, is seen that I into dl cross magnetic field. This is the now this is the vector form actually. So we have to see how the scalar format that is to be acting here is that mod of this is equal to I dl d sin theta. Because the cross product that is to be opened here in the terms of sine and the dot product is there, then that is to be opened in the cos values. So now we have to see that if dl is smaller values, because this formula is for the differential element, then we have to integrate this formula. Now we have to see what is the value constants we have to take in the outside and integration dl. What is the value of integration dl? If dl should be combined here, and this value becomes the total length of the wire, and hence we can see that IBL sin theta. This is it. So we are using this formula in how this is better on us. We have to see that current in wire, L is length of wire, theta is angle between dl and magnetic field, and d is external magnetic field. External. This formula we should apply on all the current carrying wires, but all the values, that is to be the magnetic field, that is to be the current, and the angle between dl and the current, that never changes. So we have to using this formula as a simple basis. This force may be 0 or may not be 0 after applying the conditions also, and this forces may or may not be 0, may be 0 or may not be 0, and magnetic force on the current carrying wire is equal to B. It means it may or may not be 0, and it means it is to be greater than 0. This force is to be negative values. It means the direction totally depends on the forces. If the direction of the magnetic force, we are using the law of Fleming's left hand rule, or according to this Fleming's left hand rule, we have to use this law. What is the Fleming's left hand rule? Simply says that, or we have to apply the left rule. It means we are using the left rules. This direction of the magnetic field, this direction of the current, and this direction of the force acting on the wires. It means we place the magnetic field inside here. What is the direction of the current? Direction of the current is moving in this direction, and the force acting on this wire. This is the basic law. We have to learn that how the law is applicable, and direction is more important for the magnetic aspect, because we have to calculate the magnetic field. That is very easy. We are using the formula VIL sin theta. But the direction is to be more important, because we are using the left hand rule for deciding the directions of the magnetic field.